Yeah, I thought I'd do another update. I haven't got this wired up yet. I just don't know what's matter with me. I've got no energy at the moment. I feel like shit, actually. Excuse my French. Um, yeah, I don't know. Anyway, I got this trestle thing. I literally had a tiny amount of filament. So you can probably see I've got a little bit left still, but I had a tiny bit of filament and I used some bits of plastic that was lying around or stuck on with these things to strengthen it, and I made this trestle to hold the circuit board on top. So I can just lift this off basically, sort of, it just comes off like that and it just sits on the top like that, so that when I get my wires sorted out, I can plug my wires into these sockets on here. So the four sockets down here where I can connect my wires to the coils, and it saves having jumper leads flying all over the place and a mess. And yeah, because I hate it when I've got wires trailing all over, because yeah, when it's all in one place you can just pick the whole thing up, pick the whole thing up and move it around a lot easier when it's all in one unit. um, at some point when I get round to it, I want to the drive circuit, which is at the moment is on two different boards. The timing circuit for the trigger on and trigger off coils is on that board there, and that board is what drives the MOSFET, which is over there. Right, ignore this thing over here because this isn't connected. I'm just using the heatsink as a to sync the MOSFET, but this green board that's at the back, I plan to make a new board at some point so that the trigger circuit and the MOSFET driver circuit is all on one board, and then I can mount the whole driver's board underneath at the bottom somewhere, possibly. I don't know exactly where I'm going to mount it, to be honest, but either underneath where the air is circulating, or I could even mount it on. I don't know. I'm just thinking about that, but I want to get this tidied up really at some point so that I don't have so much wires jumping all around. Because you see, at the moment I've got wires coming out of here all around to that board. Then there's wires jump from that board to this board, and then there's wires from the power supply driver circuit to that board. And yeah, it's just a mess. I hate it when it's like this. I really do. But it was all experimental and to testing everything out. And there's some other issues that I'm not happy with at the moment, and that is that I put these concentric ring magnets are actually at the bottom and the top at the moment. And because I put them at the bottom as well, I was hoping but it's actually more of a detriment because it's actually reducing the output as well. So it's not really beneficial to have these concentrics on the base near the magnet rotors, because what happens there is it actually adds to more drag, so it actually can't counter because the magnets because they effectively behave just like a piece of iron. They react with a rotor magnet. I try to keep the magnets away from the rotors if possible, and having the concentrics on the outside is ideal. So on the drive bay, I've put a magnet array which is right at the base. It's well away from the rotor magnets, so it doesn't really have an impact on the drag, or the static drag. That is when there's no load or anything. And it's yeah. So anyway, some tests this weekend, but I've just been watching snooker on YouTube right now. Judd Trump, watching the final and all that stuff right now, because yeah, I like Judd Trump. He's a good player, whatever. But yeah, so I just haven't really got to it. I got to wiring all this lot up. I got this trestle thing printed out, and it was a bit flimsy. It was a little bit wobbly, but I made some struts. So let me just take it off and show you. So I put a strut on the base of the circuit board to support it, because this board is very thin. Actually, it's very thin. It's about 0.5 millimeter thick circuit board, so it flops about a bit. And so I put this bit of scrap plastic from a previous project which had lamination stuck in, and I just cut that down because I'm recycling some plastic at the moment because I haven't got much filament left to put. I made a circuit board mount thing at both ends, and it holds this pretty well, and it's nice that I can just sit it on top like this and move it around and get it in the right position. It makes it a lot easier because then when I get my wire board, I'm not going to have 10 feet of wire. I'm exaggerating, like, but instead of having like 3 foot of wire or 2 foot of wire, it's between the coils and the board, probably just a few inches, which is great. Yeah, I know everyone's looking forward to seeing this thing running again. I am too, but I felt absolute crap the last few weeks. You know, I'm wondering whether or not I've actually had that coronavirus. I mean, I maybe have. I possibly have, but I don't know. Maybe I have, and I just don't know it. Maybe I do know it in a way. Maybe that's why I'm feeling so crap and got no energy right now. Yeah, it might be the reason. I don't know. Anyway, I certainly haven't had other symptoms. I haven't had breathing issues, which is strange. If I have, I don't know. I really have no idea right now. But some people can have it and not even know that they've had it. You see, but it can affect you in other ways. It can cause lack of energy, which is possibly why I'm feeling crap like that right now. I don't know. I just don't have the energy. Yeah, but then for the past few years I've had problems with energy anyway, so yeah, generally speaking, I just don't seem to have the energy right now. Mind you, it's probably because I've been crouching down with a fridge freezer trying to sort that fridge freezer out. I don't know. Really don't know right now. Uh, so I'm just trying to get some energy back, so I can get this damn thing wired up. I mean, it's not going to take me long to wire it up. I can push myself, yeah, but what's holding me back is not just lack of energy, it's the fact that I'm in doubt about the concentrics on the base, and I really need to wind another 2 coils, to be honest with you, because some of these coils don't have the same output. These 2 coils have more, they're underneath here, they have a lot more output than the other coils, because some of the other coils are the earlier ones that are wound. I did wind them a lot bigger, but some of them are actually using thicker gauge wire. Ideally I need to go back, I keep them all at 30 SWG wire, so they really need to be all 30 SWG wire, because it's more important to generate voltage than it is current with this particular configuration, because the cascade effect works better when you've got more voltage, because the voltages are generated and then stored in these inductors which cascade along the circuit through the triac switching circuit, and if there's not enough voltage there, then the triacs don't switch properly. Even if you've got current there, you need the voltage for it to work properly. It's hard to explain it, but you see, I found out that even when I've got a higher current winding on some of these coils, even if the winding is capable of delivering say 200 milliamps, it's not going to deliver that anyway if the voltage is too low. So you need the voltage high enough to be, I mean, I'm talking about 80 volts peak to peak on the oscilloscope. So ideally 80 volts peak to peak is really the top end voltage that you get at the very peaks of the waveforms. But it doesn't actually produce that when it's running, because there's losses in the circuitry and the inductors as the inductors are charged. So the general voltage that we end up getting out is usually around 20 volts RMS or something like that. So it usually comes out at about 20 volts RMS, and that's cascaded through the circuit, and this is how it works to reduce drag on the system. Because of the delay line system, it is a delay line. I was trying to explain how this thing works to people generally, but it's difficult to explain it in the electrical sense. But you might have seen experiments with springs. Now, I think the best way is to let me just draw something out. If you've got, I need to find a bit of paper that's got nothing written on it. If you get a spring, right, a long, why have I got shadow there? Hang on, sorry about the leads everywhere. If you've got a long spring, right, and a coil spring, right, and the spring is very long, I'm just going to draw this, and I want to show you it so you'll understand how this thing works electrically. Right, this spring is really long, right? Now, if you send a wave, if you pluck the spring at this point, then the spring, it will shoot a wave all the way through the spring to the other end. If you've got a spring that's 20 feet long and you pluck it with your finger, there will be a wave that travels all the way along the spring to the other end. Now, that's the best and easiest way of explaining it. So, in the old days, back in the 1960s, they used to use physical delay lines using springs and magnetic, where you used to induce an audio signal into a spring, and the audio would travel along this spring to the other end, and then you'd have a pickup coil which would pick it up, and that's how the old audio reverberators used to work. Well, this is similar in electrically with the way these inductors work, only there's no springs there. It's an inductive, it's reactance. It's called electrical reactance. So when you induce an inductive pulse, it tends to be absorbed into the ferrite or the magnetic material, and then it's stored in the material for a few microseconds, and then it's charged up to the next stage and so on. So you get this cascade effect. So yeah, I think that's the easiest way of explaining it physically using a spring. But let's not get confused with the fact that magnetism is not like a spring. It isn't. I'm just trying to use the analogy to try to explain how this works to people who don't kind of get it and scratching their heads trying to figure it out. So it's also, if you go out in the countryside and you see these big long power lines, and you go in the countryside, this is another way of explaining it, because this is something that goes right back to when I was little, when I was a child. You would have these massive pylons that would go up, sort of a big pylon with lots of cross structures like this, and yeah, there's lots of beams on, and you'd have power lines. You'd have these big power lines where you'd have the cables running like this across to the next pylon. Right? Do you remember those things? Well, get this damn wire out of the way. Right. Everyone's got them somewhere, and you have these. I'm not talking about the power lines themselves. I'm just trying to tell you what I'm trying to explain. So you've got these big power lines. If you remember, these power lines, these big girders things, have got guidelines. They've got these big steel wires that come down to the ground. So they've got a big steel wire that comes down and it's anchored in the ground, and to stop these pylons from tipping over in strong winds. Now, if you ever come across a pylon with a big long steel wire that runs down to ground and it's taut under a lot of pressure, and you get a stick and you tap it. If you tap the guideline pylon steel with a stick, you'll hear what sounds like wing, 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 where the sound bounces all the way to the top, it comes back down. The sound goes up to the top and it comes back down, and it gives you this weird ringing sound. Well, that is the same principle of a delay, where the wave travels all the way up to the top, bounces back down, comes back down, goes back up to the top and back down, and the audio signal just bounces up and down this piece of wire. That is what I'm trying to explain here. This is what this spring is, right? So if you know about that, or if you're in the countryside, you can test that yourself. Just get a little bit of a stick or something, just tap the wire and listen. Put your ear next to it if you can't hear it very well, and you'll hear this bing sort of twang sort of sound. Guitars do the same thing, actually. That's another thing I just realised. Yeah, guitars, they also provide something similar. When you pluck the string and you have the frets, and you put your fingers on the frets, you can get that same sort of effect where the vibration twangs up and down the string. Similar thing. So that's basically mechanically what is happening electrically. Okay. Anyway, I'm going to go now. I'm burning myself out again trying to explain all this shit, you know. Yeah, I'm going to solder some wires on it, but I don't know. I'm thinking about taking the concentrics out the bottom end because they do seem to reduce the output too much, or just take them out of the weaker coils because I'm still winding some coils in the bedroom. I've got them on the reel-to-reel. I really need to wind another four really, because four of these coils that are on here are a little bit weak. The voltage is just too low. Because if this system isn't balanced properly, if each coil set doesn't have the same output, and you're probably wondering why these two are actually taller than them two, that's because I wanted to try two different stage sets, with a smaller coil set and a larger coil set. But generally speaking, I haven't noticed a great difference between them, so they all seem to work pretty well. But the amount of difference between these two and these two is very small. We've only got like maybe 15, 20 extra steel lamination, what do you call them? Oh, I forgot what we call them now. Washers, anyway. In there, there's only a few extra in these two, but they look a lot taller, I know, but they're not that much taller, really. Probably 5 millimeters. Damn it, I keep getting my finger in the way, sorry. Anyway, so yeah, these two, yeah, don't look, I'm not that much taller. Anyway, I'm gonna go. Take care. We'll talk later. As soon as I figure out what I'm gonna do about this lamination, sorry, these concentrics, about if I'm gonna pluck them out or whatever. I'll see if I can get the energy to go and wind some more coils today. I still feel like crap actually. Yeah.